All right, now let's put together everything that we've learned in this problem here. We're going to list each of the real zeros and the multiplicity, determine whether the graph crosses or touches at each x-intercept, and then we're going to find the power function that the graph resembles for large values of absolute value of x. Don't worry about that. We'll talk about it when we get there. First things first is we're going to be dealing with zeros, multiplicity, and whether it crosses or touches the graph at each point. So what I'm going to do is I'm going to make this kind of like a table here, sort of. Okay, looking at our zeros. Our zeros, if you've worked through some of the problems that we've done before, then you'll know that our zeros come from these factors. In fact, we would have to set that factor equal to 0 and solve. So x would equal what, -4? If you understand that, then we can look at this in factored form and we can read those zeros right off of here. Our first zero, well, our first factor is 4, and that doesn't make any sense. That's a scalar multiple, so we're not going to worry about that one. But our second factor here of x plus 4, that gives us a 0 of -4. Now it happens one time. There's kind of like an understood exponent of 1 here, so its multiplicity is 1. Well, that is an odd number. So that tells us that the graph is going to cross the x-axis at -4. For our next 0, it's going to come from the next factor. So again, thinking about what we did here, if we were to set this equal to 0, x plus 3 equals 0, then our x value would be -3. Now, its multiplicity, how many times it's happening, this exponent means it's happening 3 times. Well, that's an odd number also, which tells us that the graph will cross at that x-intercept. All right, now when we talk about the power function that the graph will resemble, what they're talking about is if you were to multiply all of this out, then you would get a function that started out with what? 4 times x cubed would be x to the 4th power, and then we'd have a bunch of other stuff behind it, which we won't know until we actually multiply all of that out, and that's a little bit more difficult to do. This is a power function, and all the rest of this stuff behind it, well, and even the 4 to a certain extent, all that is doing is moving things around on the x and y plane. So whenever we talk about the power function that this resembles, we're talking about basically just f of x equals 4x to the 4th. Really, we have to look at our first or our leading term in that expansion, but we don't have to do the entire expansion. Just figure out what your first term would be, and that's what the power function that it will resemble looks like. Okay, let's try one more pretty quickly. Here we have 1, and just because it has fractions does not mean that we need to freak out at all. Again, we're going to be doing the same thing. We're going to be talking about zeros, multiplicity, and whether it crosses or touches at each one of those points. So talking about zeros, zeros come from the factors. So if I had x minus 1/3 equals 0, our 0 would be, or our x value would be 1/3. This is happening 2 times, so that's its multiplicity. That's an even number, so that tells us that the graph will touch the x-axis at that point. For the other x-intercept, we look at the next factor, and we set that equal to 0 and solve. That would be an x value of 1. It's happening 3 times, which is an odd number, so that tells us that the graph will cross at that point. And as far as our power function, we're going to look at if we were to multiply this all out, we would have an x squared times an x cubed, which is x to the 5th. So there's our power function.